Welcome to Unit 6, Day 3. Today we're going to be learning about dimensional analysis and using various conversion factors. You will need a calculator today. So, first thing we're going to ask is, what exactly is dimensional analysis? Dimensional analysis is actually one of the most useful math tools you will ever learn. And I promise you probably already do this a little bit in your head and you don't even realize it. Anything we measure will have some sort of unit of measure. Our unit can really be anything. It can be miles, gallons, miles per second, peas per pod, or pizza slices per person. It doesn't just have to be something that you traditionally think of with math. Before we get started with dimensional analysis, we need to have a set of conversion factors, or equalities. Okay? That is what it basically says. This is equal to that. So 12 inches is equal to 1 foot, for example. That's a conversion factor. Changing units is the whole point of dimensional analysis. Therefore, units are important and must be written at every step of the problem. Unlike in past units, this unit we are really going to be focusing on your work process. So please make sure you include your units because we're going to have you uploading your homework and we're going to be looking to make sure that you've written every single step. Alright. So we're going to get with a few definitions. What is an equality? Basically, all it is an expression that says this equals that. So in the example I just showed, it says 1 hour is equal to 60 minutes. So this equals that. 1 hour is equal to 60 minutes. And then if you turn over your page to the next part of your notes, it says a conversion factor is just the ratio of the equivalent values in the equality. So 1 hour equals 60 minutes, or 60 minutes is equal to 1 hour. Notice it doesn't matter which way you write it, they are both correct. And when you're doing dimensional analysis, it's really important to think about what you have on the top and what you have on the bottom. And this will be making sense more in a few minutes. But these are different ways of saying the same thing. So more about conversion factors. Conversion factors are ratios. Okay, so a conversion factor is a ratio whose numerator, the number on top, and denominator, the number on the bottom, are equivalent measures. And that's why it doesn't really matter. It's true that 1 foot is equal to 12 inches, but you could also say 12 inches is equal to 1 foot. Okay? Their numerator and denominator are equivalent. So, a lot of these are really common and you probably already know. 1 foot is equal to 12 inches. 1 meter is equal to 100 centimeters. 1 pound is equal to 16 ounces. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. And 1 day is equal to 24 hours. So, we have on Canvas a list of common conversion factors, and you'll notice it says that it's the 3rd grade, I believe, star chart. So you've actually been working with these conversion factors for a long time. But you don't need to memorize conversion factors, we will provide them for you. Okay, so when we are solving these problems, there are a few essential questions we need to ask ourselves. First, what is the given unit? Second, you want to ask yourself, What is this question even asking for? Or what units should be in the answer? And finally, what conversion factors do I need to use? So every single dimensional analysis problem, you'll go through and kind of think about these questions. We call this the guess process. So when solving equations, you must guess, but don't really guess, just know that this stands for, think about your givens, your unknowns, the equation, substitute, and then solve. I tell my students to always box what the problem gives them and circle your unknowns. That makes it very simple to work through these problems. Okay? So always box your givens and circle your unknowns. And you're going to hear me say that a lot throughout this video. Alright, so here's how we're going to choose our conversion factor. First, write the given with units. You have to write those units in your first blank. Then you're going to write the first conversion factor with the given unit on the bottom so it cancels out. We call this discoing down. So disco, that was the dance. You can see the little minion. He's doing a little disco dance up there. So we disco down, and you'll see what I mean in a minute. If the unit you need is in your answer is not on the top, use another conversion factor. You may need to repeat this several times. Okay? You're going to check your work by canceling out the units as you go. Let the units do the work for you. So, this is what that will look like. You're going to build these little T-charts when we solve dimensional analysis. These dimensional analysis problems, it's just a way that we can convert very easily. This T-chart formula is the same as how you might have seen it before, but I really like writing it with the T-chart method. So that's how you're going to see all my work. Okay? And now I'm going to switch over to the document camera, and we're going to get to solving these problems. Alright, so let's put this into action. So our first problem says, how many seconds are in 1.4 days? Remember how I always said to box your givens and circle your unknowns? Okay, so what I am given is 1.4 days. What I'm looking for, my unknown, is seconds. So what am I given? I box my givens. I'm given 1.4 days. What do I want to know? How many seconds? Okay, you want to know how many seconds there are in 1.4 days. And then it says, what conversion factors or equalities can I use? Okay, so we know these. 1 day, okay, is equal to 24 hours. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. Alright, so now I've written out all my information that I need to know, and now I can just plug it in. You always start these types of problems, make a little T-chart, and you always start with your given. Every single time. Always start with your given. My given is what I boxed. So 1.4 days. Then I'm going to disco down my unit. Not the number, just the unit. So I'm going to disco down days. And then I'm going to look at my conversion factors. So okay, 1 day is equal to 24 hours. So I'm going to say, all right, I disco down my unit. And then I need to use my conversion factor. 1 day is equal to 24 hours. Disco down, because have I gotten to what I circled? Am I at seconds yet? Nope, so I have to do another conversion. Disco down, just bring down the unit, hour. And then I'm going to use my next conversion factor. 1 hour is equal to 60 minutes. 1 hour is equal to 60 minutes. Have I gotten to seconds yet? Nope. I need to do another conversion factor. So once again, I'm going to disco down my unit. Disco it down, bring it down. I'm going to write minute, and then I'm going to fill in my final conversion factor. 1 minute is equal to 60 seconds. All right. Then, in order to calculate, to get the final answer, you're going to multiply all the numbers on the top. Then you're going to multiply all the numbers on the bottom. And then you're going to divide the top answer by the bottom answer. Okay, so what does that mean? I am going to put into my calculator 1.4 times 24 times 60 times 60. That's multiplying all the numbers on the top. So I'm going to get my calculator here and do just that. 1.4 times 24 times 60 times 60. Hit enter. You can write this answer out. If you use parentheses, you can do it all in one discrete step, but if you don't like using parentheses, and some students don't, you can write this out. So if you want to write that out, you can say, now I'm going to do the same thing for the bottom. Oh, these are all 1. So I don't really need to use a calculator for that, because 1 times 1 times 1 is equal to 1. There will not always just be 1s on the bottom though, so don't get used to that. So I'm going to take them and divide the top answer by the bottom. And that is, of course, equal to this number right here, 120,960 seconds. That is how many seconds are in 1.4 days. Okay, and I always tell students, just box your final answer just so we know. Okay, let's do the next problem. And we work these the exact same way. So I'm going to grab a different color. All right, same thing. Always start these problems by boxing your given. So here it says, how many hours are in 1.5 years? This is my given, and I'm looking for hours. What am I given? 1.5 years. What do I want to know? The hours. Then the equalities, I have to figure out my conversions in order to get there. So 1 year is equal to 365 days. 1 day is equal to 24 hours. And then we always start by drawing off our T-chart, and then always start with what you boxed. Always start with your given. So 1.5 years, I'm going to disco down, not the number, the unit. That's why if you don't write your units, you're not going to know how to solve these problems. Disco down my unit. 1 year is equal to 365 days. I'm going to disco down my unit. And then it says 1 day is equal to 24 hours. And then I'm going to solve it just like I did before. We're going to multiply all the numbers on the top, multiply all the numbers on the bottom, and then divide the two. Just like the previous problem, there are only 1s on the bottom, but that is not always going to be the case. So don't get in the habit of always thinking that there only can be 1s on the bottom. But in this case, I'm going to say 1.5 times 365 times 24, and that gives me my final answer, because of course this is just 1s, so if we multiply and divide by 1, it's not going to change the final answer. So there are 13,140 hours in 1.5 years. There's my answer. Okay, so remember how I was telling you ones are not always on the bottom? This is a great example of how that is true. Okay, so let's say you are going to be throwing a pizza party, right? So you're throwing a pizza party. I need to actually, there we go. We're throwing a pizza party, and you are going to have our blanks here. We've got 15 people, and we figure that each person might eat 4 slices, and then you want to know how much this party is going to cost you. So you need to get some information from the pizza place. So you call the pizza place, and then they tell you each pizza is going to be $14.78, and that each pizza will have 12 slices. You got that information from the pizza party. Okay, so we are going to go back to, we went back to the document camera, so we have all this information. Here's your party. We want to figure out how much is this pizza party going to cost me here. All right, so what are you given? Okay, let's think about what is our given. We've invited 15 people, so that's where we're starting. My given is that there are going to be 15 people at my party. What do you want to know? How much is it going to cost you? We're trying to figure out the cost. Okay, so we always do all your use your conversion factors. Okay, so at my party there's going to be 15 people. Okay, and every single person, we think they are very hungry, and each person is going to eat 4 slices of pizza. You think your friends are pretty hungry. Okay, there are 12 slices in one pizza when I called the pizza place, and they told me that every single pizza was going to cost $14.78. All right, so let's always begin with what we are given. And my given is that my party is going to have 15 people. 15 people. All right, I'm going to just go down. Usually we take the unit, but I'm going to change it to person because my next conversion is that I think every person is going to eat 4 slices. So, people, person. Okay. So, at the party, I think they're going to have every one person is going to have 4 slices of pizza. Okay, I'm going to just go down my unit, slices, just go down, and then I'm going to use my next conversion factor. There are 12 slices in one pizza. 12 slices is equal to 1 pizza. And then I'm going to just go down, pizza, and look at my final conversion factor. 1 pizza is equal to a cost of $14.78. Okay, now we're ready to solve. So look, this time we have something that is not just a 1 on the bottom, so we're going to want to be a little more careful. So I'm going to take all my numbers on top and multiply. So I'm going to say 15 times 4, okay, times 1 times 1478. Hit your equal sign. Like I said, if you want to, you can do this in 2 discrete steps, or if you use parentheses, you can do it all at once. So I'll show you both ways. Ooh, that last number should be 8. So that's just all these numbers multiplied together. Now I want to do the same thing on the bottom. So 1 times 12 times 1, and that of course is equal to 12. And then my final step is to divide the numerator and the denominator, the top and the bottom. So I'm going to take that 886.8 and divide it by 12. Okay. And so there it is. There's my cost. This party is going to cost me $73.90. That is a lot of money. So you know you've finished if at the end you've answered, what do I want to know? You wanted to know the cost? There it is. That's going to be the cost of your pizza party. Okay, so let's keep practicing. Next page, it says, at 20 weeks gestation, a baby is about 17 centimeters long. How many millimeters is this? I like this question because this gives you some useless information. Really, we're just trying to convert from, this is my given, 17 centimeters, and this is my unknown, millimeters. This 20 weeks, I don't need at all, so you can cross that off. So I've asked my big questions, are boxed and circled, and you always start with your given. So 17 centimeters, I'm going to just go down, centimeters, and what am I looking for? I'm looking for millimeters. Okay, so you just have to think, what is my conversion factor? How many millimeters are in a centimeter? Okay, so in every 1 centimeter, okay, you've got, and we have a chart for you. I will show you this, because you don't have to have these memorized. Make sure. Maybe it's on this page. There. Well, we're going to give you these star charts, but my answer here is going to be 10. Okay, but we're going to give you a star chart. So you can solve this one in your head actually, because you just have to multiply everything on top. 17 times 10 divided by 1, right? So, but you're always free to use a calculator if you want to. But your answer is going to be 170 millimeters. All right, so our next question says, how many centimeters are in a 10-kilometer run? So here's my given, and that's not a very bright color. Let me switch something a little more bright. I'm looking for how many centimeters are in a 10-kilometer run. So box your givens and circle your unknowns. And here, look, we're going to make you draw the little chart, but they all look the same. Okay, always start with what you are given. I've been given an amount of 10 kilometers, and then I'm trying to get to centimeters. So I did locate my star chart, and this is attached to your packet and on Canvas. And it says that 1 kilometer is equal to 1,000 meters, and that 1 meter is equal to 100 centimeters, but we're only trying to get to centimeters. We can stop there. We don't need millimeters. So I'm going to just go down my unit, that's the kilometer, and then fill in my conversion. So 1 kilometer, we looked on the conversion chart, is equal to 1,000 meters. 1,000 meters, but I'm looking for centimeters, so I have one more conversion to do. Just go down. 1 meter is equal to, right, just from my chart, 100 centimeters. you know you finished with all the conversions if what you ended up with matched what you circled. So this is just a lot of multiplying, right? So I'm going to say only one's on the bottom, so I really only have to worry about the top in this problem. 10 times 1,000 times 100. Okay, so a whole lot of zeros. Okay, that's 1, 2, 3, 4, 5, 6 zeros. Okay. Okay, and my answer with units, right? There we go. All right. Next problem. Okay, if Jessica runs 3.1 miles, how many meters is this? Box your given, circle your unknown. And then I always draw my little chart and start with what I was given. Okay. Again, use your conversion chart. You want to be looking for that conversion chart. We're trying to go from miles to meters. So we want to make sure we get my conversions. So here I wrote out from my conversion charts 3.1 miles. How many meters? So I only have one choice. 1 mile is equal to 1,760 yards. So I wrote that out. Okay. Now I'm going to just go down again because I'm not looking for yards. I'm looking for meters. So just go down again, yard. And then I'm going to check what my choices are. I don't have a conversion to get straight from yards to meters, but I do have, and remember I'm at yards and I'm trying to get to meters. I do have yards and feet. So it says 1 yard is equal to 3 feet and 3.28 feet equal 1 meter. So I can get there. It's just going to take a few steps, but that's okay. So 1 yard is equal to 3 feet. Okay, just go down because I'm not there yet. I'm looking for meters. So I want to see my conversion here. 3.28 feet is equal to 1 meter. And this is a good problem I like a lot because we have so many things in the bottom that aren't 1. So remember, to solve, we're going to take everything on top and multiply. And then we're going to do the same thing with the bottom. I like to do this with parentheses. Remember how I said you can do it in 2 steps? But I would also show how you can do it in 1 single step. And that is going to be with usage of parentheses. So in a parenthesis, you can multiply everything on top, 3.1 times 1,760 times 3 times 1, close your parenthesis, okay? Then we're going to hit divide, and that allows me to do this in a single step. Open a new parenthesis, and remember, you multiply everything on the bottom. So you're going to say 1 times 3.28. Close that parenthesis, and then hit enter. Okay. So there's my answer. How many meters are in 3.1 miles? That is going to be 4,990.24. I'm going to round that. You don't have to write all those digits. So and remember, you have to include your units with units. Meters. That's my unit. All right, one more problem. When eyes are dilated for an eye exam, they expand to 5 millimeters. So this is my given. I'm going to box that, and I'm looking for inches, okay? Draw your little square, your T-chart, and then you always begin with what you are given, 5 millimeters. And I want to think, how can I get there? I'm going to check my chart. Okay, so I'm trying to get to inches, but I only have millimeters right now. So here we go. There's not that many places on here where I can use millimeters. In fact, there's only one. So I have to use this conversion. Okay, so my first conversion is going to be 10 millimeters is equal to 1 centimeter. So just go down, millimeter to centimeter. 10 millimeters is equal to 1 centimeter. But that's not what I'm looking for, right? I'm looking for inches. So I gotta just go down again, bring down my centimeter. Okay, so I'm at centimeters and I'm trying to get to inches. What is my conversion factor? Okay, so for every 2.54 centimeters, that equals 1 inch. So I'm going to write 2.54 centimeters is equal to 1 inch. And now I've got to what I circled. So I'm all done. I'm ready to do my math. Multiply everything on the top and then divide it by everything on the bottom multiplied. So once again, I'm going to do it all in one step using the parentheses. I'm going to say parenthesis 5 times 1 times 1. Close my parenthesis, hit divide, open a new parenthesis, 10 times 2.54. Close your parenthesis, hit enter. How many inches is this? Okay, this is less than an inch, and that makes sense because a millimeter is much smaller. Okay, so I'm going to round it. I'm going to say 0.19. I'm going to round this 6 up to a 7. And what is my unit? That's inch. And I'm all finished. So I promise this works every single time. This this reference chart is on Canvas, and it's also in your packet if you are picking up a packet from Oak Ridge. And now let's do our homework. Great job.